Welcome to Study Loop.
Initial pressure of ideal gas is 2.20 times 10 to the power 5 Pascal. So Pi equal to 2.20 times 10 to the power 5 Pascal. So final pressure is 8.15 times 10 to the power 4 Pascal. Initial volume of gas is 6.34 times 10 to the power minus 3 cubic meter, and for ideal monatomic gas we have gamma equal to 5 upon 3. Now in the first process, that is adiabatic process, we can write final pressure times final volume to the power gamma is equal to initial pressure times initial volume to the power gamma. So this gives us final volume to the power gamma is equal to initial pressure upon final pressure into Vi to the power gamma. Now by taking power of 1 upon gamma on both sides, so this will give us final volume equal to initial pressure upon final pressure whole to the power 1 upon gamma into initial volume. Now by plugging different values in the relation, final volume equal to, here initial pressure is 2.20 times 10 to the power 5 Pascal upon final pressure is 8.15 times 10 to the power 4 Pascal whole to the power 1 upon gamma. Here gamma is 5 upon 3 into initial volume is 6.34 times 10 to the power minus 3 cubic meter. This gives us final volume equal to 11.5 times 10 to the power minus 3 cubic meter. The relation for work done in a adiabatic process is work done equal to initial volume into initial pressure minus final pressure into final volume upon 1 minus upon gamma minus 1. Now by plugging different values here initial pressure is 2.20 times 10 to the power 5 Pascal into initial volume is 6.34 times 10 to the power minus 3 cubic meter minus initial pressure is 8.15 times 10 to the power 4 Pascal into initial into final volume is 11.5 times 10 to the power minus 3 cubic meter upon gamma minus 1. Here gamma is 5 upon 3 minus 1. So this gives us work done in a adiabatic process equal to 6 and 6.325 joule. Now we want to calculate the work done in the alternative process. In the alternative process, the gas is cooled isochorically first to the final pressure, then it is isobarically expanded to its final volume. So again here in the isochoric cooling we have initial volume equal to final volume, that is 6.34 times 10 to the power minus 3 cubic meter. So here initial pressure is 2.20 times 10 to the power 5 Pascal, and after cooling to the final pressure we have final pressure equal to 8.15 times 10 to the power 4 Pascal. As there is no change in volume, so delta V is equal to 0. This gives us work done also equal to 0 because of no change in volume. Now in the isobaric process, isobaric expanding, we can calculate work done by the relation W equal to P into delta V. Here pressure is constant at 8.15 times 10 to the power 4 Pascal into final volume is 11.5 times 10 to the power minus 3 cubic meter minus initial volume is 6.34 times 10 to the power minus 3 cubic meter. This gives us work done equal to 420.54 joule. Now we can calculate the total work in the alternative process. So the total work in the alternative process equal to work done in the isochoric cooling, that is 0, plus work done in the isobaric expanding, which is 420.54 joule. So this gives us total work equal to 420.54 joule. Now we want to calculate the difference in the work done when work is done on the gas adiabatically and in the alternative process. So the difference in work done equal to 6 at 6.325 joule minus 420.54 joule. This gives us difference in work done equal to 265.785 joule. That's the end of the problem. Thanks for watching.